Looking at our component location for the EGR, here we have the EGR along bank number 2 in the front of the engine with our electrical connector. In case you don't know how an EGR valve works, here we have a cutout EGR valve that is very similar to another vehicle that we have in lab, being our Acura TL. So here on the top, that is going to be your pintle position sensor and potentiometer. And you see here, when I press this spring down, that follows along the resistor strip inside there. In the middle, you've got your coil of wire, which you can easily ohms check. And down here, you press this spring, that is going to be your valve that opens and closes. Looking at our wiring diagram here for the 1999 Acura TL for the EGR system, starting with this white and black wire coming out of the PCM. This is where it comes out of the PCM and goes right into the potentiometer. That is going to be our signal circuit. And this yellow and blue wire coming out of this junction connector and going into part of the potentiometer, that is going to be our power wire. And then this green and black wire comes out of the potentiometer, comes to a common ground, that is going to be our ground wire. Same here for the magnetic coil coming from the PCM, that is going to be our power wire on a pink wire, and then ground for the coil, that is going to be a black wire. So here, going across the potentiometer of the EGR, here we can see when we're hooked up we have 4,000 ohms, but when we jump into the battery we go down to 1,600 ohms. So it looks like our position sensor is working on the EGR.
Explain what we're doing here.
So here we are going to be bench testing the EGR to see if our valve opens and closes. So what I'm going to do, I'm going to take this jumper lead, put on the negative terminal of the battery, and our positive lead, and put that on the positive terminal of the battery, see if our valve opens. So what you can see here, when I put the positive lead and create a circuit, you can see that the valve fully opens and fully closes. Though compared to the PCM, it may not open that valve completely. So if I were to try and be the PCM, I would have to connect the circuit multiple times in quick successions to try and keep that valve hovering or open at a certain point.
As you can see here, we have a permanent DTC of PCM internal circuit failure. This may be the cause of why our EGR isn't functioning properly.
Looking at our component location, on the right rear of the valve cover, this is where our PCV valve is going to be. And then coming from the PCV valve all the way down to the intake, that is going to be our suction line. Then right here, from the valve cover to the intake, that is going to be our fresh air inlet. Another way you can tell that this is a variable PCV valve is when you shake it, you might hear a little bit of a click inside of it. Looking at the condition of our PCV valve, we see that it's relatively clean for its age, but you still see a little bit of oil build up on the valve itself. Here we are going to be unplugging the hose that comes from the PCV and runs all the way to the intake manifold. As you can see, the car runs very rough, but if I plug, nope, it died. Here's attempt number 2 of taking the hose out from the PCV. If I keep my thumb over it, we can see that the engine still runs perfectly fine. But now, since the hose is pulling a suction on my thumb, we ensure that there's proper vacuum going through the system. And create a slight vacuum leak by just lifting my thumb off a little bit. You see that here that the engine bogs down a little bit. Take completely off, bogs down, put it back on so it doesn't die. Do this a couple times. If the engine runs really rough, let's plug it back in. I'm going to be testing airflow at the PCV valve. And so I've got my vacuum gauge hooked up to the suction side of the hose to prevent the engine from stalling. And since the engine's hot, I'm going to be using this piece of paper. So I'm going to be putting this piece of paper in front of the outlet of the PCV. Putting it on the PCV, feels like there's no suction coming from the PCV. And putting it in front of the PCV, it looks like there's no airflow coming out of it that would be pulsating the piece of paper. In this test, we're going to be taking the oil filter cap off and putting a piece of paper on. See if we have pressure in our crankcase. You can see when the obnoxious noise and flapping is doing, we have pressure inside of our crankcase. Looking at our component location, here is our EGR valve on the Buick, and taking a look at our wiring as well. We have gray wire, black wire, brown wire, another gray wire, and a white wire. Coming over here to our connector view for the wiring. See that pin A is a gray wire. That is going to be our EGR valve control. Pin B is going to be that black wire, which that is going to be our EGR pintle position sensor ground. And then pin C, that is our brown wire. That is going to be the signal wire for the pintle position sensor. And then pin D, that is going to be a gray wire. And that is going to be the 5-volt reference wire. And then pin E, that is going to be our white wire, and that is our EGR valve control.
So here we have our live data. We have our maps, our map readings over here, and then our EGR information on here. We have our feedback, our position, and our duty cycle. And when we put the car into gear and accelerate it, you can see that the values change. You can see the duty cycle is given in as a percentage. We have our feedback and voltage. And then we have our pintle position right here. It's given as a voltage reading.
Here we're going to see how the vehicle runs with the EGR valve unplugged. Unplugged. Looking at our scan tool after unplugging the EGR valve, we have a P0403 code, which is EGR solenoid circuit, and then a P0505 code, EGR valve position sensor circuit low voltage. So here we have our Buick 3800, and with our, coming over here to our component diagram, you can see that this is an integral. So here we have our map sensor, the spring clip that holds it in, and right here's our PCV that sits right down this little cup. We're going to come over here, remove our map sensor, flip out, and then take a 16mm socket or wrench, then twist this off. Here we have our little spring, and then right down here is our PCV. Should just pull right out. And here you see that this is a variable one, and as well too we can do a shake test with this, and the shake test can sort of tell you if the PCV is bad or not. It should have a little bit of shake, but if it does shake, it might also be a bad PCV. Here's some extra research on our 1999 Buick LeSabre, adding on to previous clips that we have shown or clips that were not added in the video. Number one, inspection of the PCV system. It looked very clean. It may possibly have been replaced in the past, looking how there was very little buildup on it, and it looked very shiny, like right completely out of the box. It did have a light film of oil on the outside, and there was no visible buildups or clogs. It did rattle when shaken around. This may possibly indicate a weak spring, but we cannot condemn a shaking PCV as a bad part. And then number two, our crankcase pressure / vacuum test with a sheet of paper. I removed the oil cap to see if there was vacuum in the crankcase. Instead, I was met with a lot of blow-by gases coming out of the oil filling cap. No vacuum was present at all. Tried the oil dipstick tube as well to see if there was any vacuum. Same result as before. This may indicate that the PCV system is broken, or there might be a clog somewhere that is not letting pressure escape, or possibly the piston rings are worn and it's causing too many blow-by gases to pass the pistons. There is no sludge on the oil cap either.